This is some extra related info to our project by Daniel Choi and Simon Yoon from 8C. And the first thing deals with atomic theory development. Democritus was the first person in ancient Greece to come up with the theory of the atom, and John Dalton, an English schoolteacher, later supported it. They both thought that an atom was a perfectly spherical just shape that made up everything in the universe. After the discovery of electrons by J.J. Thomson, what ended up the next model became known as the plum pudding model, where the electrons were scattered out randomly and evenly, just like the plums in a plum pudding. Now, after Ernest Rutherford discovered the proton and James Chadwick discovered the neutron, and therefore our complete version of the nucleus, this version of this model came out with the electrons spinning randomly around the orbits. And then came the idea of electron shells, and after that, uh, after the idea that electrons might behave as waves, the electron cloud idea came about. Now, the electron cloud idea is the idea that electron, could be technically, theoretically, any distance from the nucleus, but the electron cloud is where it's most likely to be. Now, with quantum theory, there started to be more complex mathematical calculations about the electron cloud, and the series of diagrams you see right there is the s orbital, the p orbital, and the d orbital, and then the after that is the f orbital. And as you can see, there are more various, like different types of each orbital as you go along, and the shapes become weirder and weirder. So like the s orbital is a perfectly symmetrical shape, so the electron can theoretically be anywhere within that orbital. However, in the next orbital, you see that there are two areas in which the electron is more likely to be in according to probability, and that is the idea that quantum theory is based on. Now, while we were discussing the solubility of salt in a previous stage, there came up the issue of, is salt dissolving a physical or a chemical change? Now, usually in cases of solubility, where anything dissolves in water, it's a physical change with the atoms and molecules fitting in with each other. But in the case of salt, it's slightly different, because water is a polar molecule in that the oxygen atom in a water molecule is negatively charged, and the hydrogen atom is positively charged. Now, in NaCl, which is table salt, the sodium, Na, is positively charged, while Cl is negatively charged. This means that when salt is dissolved in water, what's actually happening is a chemical change, but not a physical change. What's happening is that sodium is actually a positively charged ion, and that ion is breaking apart from the negatively charged chlorine. So the water, a polar molecule, is actually breaking apart the bond of the uh, salt molecule. It's breaking apart the ionic bond that forms them, and then it's actually forming a very weak bond, well, very weak ionic bond between the oxygen atom in the um, water molecule and the sodium atom in the original salt molecule. Now, when water is later evaporated out, what happens is the very weak ionic bonds that formed between oxygen and sodium and chlorine and hydrogen, they break apart, and water becomes water again, H2O, and salt becomes salt again, NaCl. Water forming another covalent bond, and salt forming an ionic bond all over again. So it is technically a chemical change, but salt is unique in this, and no other soluble substance that we know of does this.